Then
No. Sure. So let's
okay.
get started without any further ado. So again, as mentioned, today we'll be starting with the topic called networking fundamentals. Okay. This is one of the most important prerequisites for cybersecurity. Okay. And when you talk about networking fundamentals, there are three important definitions to go through with. Okay. So firstly, there's something called as networking. Then there's networks, and then there are hosts. When you talk about networking, this is the practice of connecting information devices with each other so that you can share information or resources. Okay. So the practice of connecting any sort of information device with others is called as networking. Okay. So connecting your phones to your router, your laptop to your other printers or firewalls or databases or web servers, whatever it is, having a connectivity of all of these devices is called as networking. Okay. And the collection of that devices together, or the group of those interconnected devices is called as a network. Okay. And each device in that network is individually referred to as a host. Okay. As mentioned again, computers, printers, routers, mobile phones, web servers, IP cameras, speakers, okay, Bluetooth speakers, smartwatches, okay, and again, headphones, okay, whatnot. All of these are individually called as hosts. Just like how we humans have names to address each other, these devices also have a name. That name is called as an IP address, Internet Protocol address. Okay. Built by by the US military in the 1950s or so, there were multiple versions of it. IPv1, which is IP version 1, IP version 2, and IP version 3. They were not quite successful. What properly worked out was IPv4, Internet Protocol version 4. Okay. And we're still using that IPv4 addresses even in today's world. Okay. So to define an IP address, as mentioned, each device on the network has an identity. Each host on the network has a unique identifier. And that unique identification is called as an IP address. Okay. And that IP address allows for communication to occur between the hosts. Okay. As mentioned, this IP address now has a few important properties to it. Firstly, it's a 32-bit address. What I mean by 32-bit is that it contains 32 zeros or ones. Each bit is either equal to the value of 0 or the value of 1. That's the smallest data that a computer can hold. Okay. And your IPv4 address consists of 32 bits. Okay. And that entire 32-bit portion again is divided in four equal parts of 8 bits each. And that 8-bit portion is called as an octet. Okay. And each octet is separated by a dot symbol. So this is typically what your IPv4 address looks like. So as you can see, 8 bits here, then a dot, then 8 bits here, then a dot, then 8 bits again, then a dot, and then 8 bits. Okay, 8 fours are 32-bit address. So this is what your IP address typically looks in the computer readable language, also commonly known as the binary language. Binary in the sense the language of zeros and ones, only two characters. But what we humans regularly use or understand are decimal numbers, numbers from 0 to 9. Okay. So this number 11000000 is actually equal to 190. This number 10101000 is actually equal to 168. This number 00000000 is actually equal to 0. And this number 00001010 is actually equal to 10. Okay. So now we shall learn how do you convert any binary number to a human readable decimal number. Okay. Any questions or doubts up to this point? Vishwamitra, Mahid, Joseph. Yeah.
No,
Okay.
sir.
So, okay. Mahid, any questions? No, your voice is not audible, Mahid. I can't hear you. You did unmute your mic, but I still could hear you. Hello? I think there seems to be some issue with your speaker or your microphone, actually. I am unable to hear you, man. But let's hope there are no questions. Okay. Moving forward, let's talk about the conversion. So as mentioned, you can convert any of these numbers from binary to decimal. Okay. Now to convert any number, there are two simple rules. Rule number one is once you have written down the binary number as such, let's say we take this number here, 10101010. To convert this number now, firstly, you write down the values of 2 power 0 all the way up to 2 power 7 from right to left. So under each bit, you write down the value. So the rightmost bit has 2 power 0 under it. Then you have 2 power 1, then 2 power 2, then 2 power 3, then to power 4, then to power 5, then to power 6, and finally to power 7. So under each bit, you're writing a value of 2 power, starting from 2 power 0, going all the way up to 2 power 7. Okay. Once those values are written, you multiply the lower value with the top bit and keep on adding it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay. And when you calculate and get the final number, that would be the conversion of binary to decimal. Okay. So we try to calculate this now. Let me write down the values for 2 power numbers first. 2 power 0 is 1. So anything to the power 0 is always equal to 1. That's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2. That's 4. 2 power 3 is 2 into 2 into 2. 3 times. That's 8. 2 power 4 is 2 into 2 into 2 into 2. 4 times. That's 16. 2 power 5 is 2 into 2 into 2 into 2 into 2. 5 times. That's 32. 2 power 6 is 64. And 2 power 7 is 128. Okay. Now, once you know these values here, as mentioned, you multiply the lower value with the top bit. So 2 power 0 into 0. That is simply 0. 2 power 1 into 1. 2 power 1 is 2. Into 1, that's 2 itself. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. Oh, sorry. 1 second. Can't. Yeah, sorry. So 2 power 4 into 0, that's 0 again. 2 power 5 into 1, that's 32. 2 power 6 into 0, that's 0 again. 2 power 7 into 1, that's 128. And now when I add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. Something like high frequency, low frequency, high frequency, low frequency, high frequency, low frequency, high. Okay. So when that sequence of frequencies flows through a computer stream, through the stream of data, the computer understands the stream of data as 170. Okay. Is that clear? Vishwamitra, Joseph, Wahid.
Yes, yes, clear.
Okay, assuming this is clear. Now, if this is clear, guys, I have two other numbers here. If you notice on the screen, I want you to calculate the decimal answers for these numbers and give me the value. Okay, so the first number is 0101010, and the next number is all ones. Take your time, no rush. Calculate the answers and give me the decimal value for both these binary numbers. Okay, perfect. So I've got a couple answers, guys. Some again, I've got answers as the first one for 85 and the second one as 255. Okay, so correct answers, guys. So as again, let's try to calculate them just in case if you've got a different number. So 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0 plus 2 power 4 into 1 plus 2 power 5 into 0 plus 2 power 6 into 1 plus 2 power 7 into 0. So wherever there's into 1, you write the value there. Wherever there's into 0, you write 0 there. Okay. 2 power 0 into 1, that's 1. 2 power 1 into 0, 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, 0. 2 power 6 into 1, that's 64. And 2 power 7 into 0, 0. Okay. And if you add all that up, 64 plus 16 plus 6 plus 4, you get the number 85. Okay, the first answer. And the next number, when you put all ones, you get 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And for that, the answer is 255. So correct answer, Mr. Mitra. Correct answer, Mahida as well. Josephine, oh yeah, you've given the correct answers as well. Perfect answers, guys. Okay. Now, the reason I've been explaining all this is so that we can understand the range of IP addresses. So if I had to get the first IP, all I have to do is simply put all zeros everywhere. So the first octet all zeros, second octet all zeros, third octet all zeros, fourth octet all zeros. And when I put all zeros in the binary numbers, what do I get in decimal? Simply 0 dot 0 dot 0 dot 0. And if I had to get the last IP, I simply put all ones. That's the maximum number. And when I put all ones, you just calculated and gave me the answer as well. It's 255. So the last IP would be 255.255.255.255. Okay. So this is the entire range of IPv4 addresses. Okay. You can never have an IP in the negatives or in the positives above 255. Okay. Whatever IPs you have, they would always range from the number 0 to 255 itself, not more than that. Okay. And we know the logical reasoning behind it. When you put all ones in the octet, maximum it can go up to 255 itself. It cannot cross that. Okay. And from this, we can also understand the total number of IPs as well. So each bit here has two possibilities, 0 or 1. And you have a total of 32 bits. So if you had to calculate the total number of IPs, it would be 2 into 2 into 2 into 2 into 2 into 2 into 2, as such 32 times. So the total number of IPs can be calculated with a simple combination of 2 to the power 32. And that would approximately give you 4.3 billion IP addresses. So when these were built in the 1950s also, 4.3 billion IPs did seem like a very large number, because back in 1950s, you had no mobile phones. Rarely people owned computers. Okay. So unless and until it's the military or the government or a very well-known recognized organization, they hardly had computers then. Okay. So 4.3 billion IPs seemed like a very large number back then. Okay. But fast forward to 2024, each person has multiple devices and the population itself is 8 billion people. So again, 4.3 billion IPs assigned individually to each system would not have been sufficient. That's why they categorize these IPs into various parts again. There's something called as classes, there's something called as public and private IPs, etc. We'll talk about that in the upcoming sessions. Today, we're going to end the session with the sequence of IPs. So we know this is the first IP, and we know this is the last IP. Let's talk about the sequence of IPs now. Okay. So to understand the sequence of IPs, again, there are two simple rules, guys. Okay. Rule number one is you write down the IPs or increment the IPs from the rightmost bit. For example, now we all know this is the first IP here, 0, 0, 0, 0. Okay. If I had to get the next IP, according to rule number one, always start incrementing from the rightmost octet. So after 0, 0, 0, 0, next IP would be 0, 0, 0, 1. Next IP, 0, 0, 0, 2. Next IP, 0, 0, 0, 3. Next IP, 0, 0, 0, 4. Next IP, 0, 0, 0, 5. So as you can see, the rightmost octet increments by 1. And this would go on to a value up to 255. Okay, so you have 253, 254, 255. Now, once it reaches the maximum value here, please note, it cannot go up to 256 now. Okay, so it cannot exceed 256. That's illogical. Okay, and that is not possible in IP addresses. Okay, so once it reaches 255, now here comes rule number 2. So once the rightmost octet reaches a maximum value, then you move to the left octet. So this is 255 now, cycles back to 0 or resets back to 0. And the left octet now, this 0 now changes to 1. So you have 1 0 after 0 2 3 5. Okay. After 1 0, don't directly jump to 0 0 2 0. That would be wrong again. Remember rule number 1, always increment from the rightmost octet. So after 1 0, you have 1 1 again. Then 1 2. Then 1 3. Then 1 4. Then 1 5. Then 1 6, which goes all the way up to 1 2 5 5. Okay. Then you have 2 0, which goes up to 2 2 5 5. Then 3 0, which goes up to 3 2 5 5. Then 4 0, which goes up to 4 2 5 5. Like that, the cycle keeps on repeating. So there's a pattern forming here, if you notice. 0 0 to 0 2 5 5. 1 0 to 1 2 5 5. 2 0 to 2 2 5 5. 3 0 to 3 2 5 5. Goes on all the way up to 2 5 4 0 to 2 5 4 2 5 5. 2 5 5 0 to 2 5 5 2 5 5. Once both these octets are filled now, they cycle back to zeros again. And this 0 now changes to 1. And you have 0 0 again now. So 0 0 goes up to 0 2 5 5, 1 0 goes up to 1 2 5 5, 2 0 goes up to 2 2 5 5, and similarly 2 5 5 0 goes up to 2 5 5 2 5 5 again. So this one now changes to 2. So whatever cycle repeated here from 0 0 0 to 0 2 5 5 2 5 5, same repeats again from 1 0 0 to 1 2 5 5 2 5 5, 2 0 0 to 2 2 5 5 2 5 5, 3 0 0 to 3 2 5 5 2 5 5, 4 0 0 to 4 2 5 5 2 5 5. And similarly down the line, 25500 to 255, 255, 255. Once all these three octets are full, this final 0 now changes to 1. Okay. And whatever cycle now repeated from the first IP, 0, 0, 0, 0 to 0, 255, 255, 255. Same cycle repeats again from 1, 0, 0, 0 to 1, 255, 255, 255. Then 2000 to 2255, 255, 255. 3000 to 3255, 255, 255. 4000 to 4255, 255, 255. And similarly down the line, finally you have 255000 to 255, 255, 255, 255. Is that clear, everyone? How the sequence of IPs flows. And if you keep on counting each and individual IP there, you'd get approximately 4.3 billion IP addresses from the first one till the last one. Any questions, Vishwamitra, Josephine, Mahid?
No, sir, no questions.
Okay. Now, as mentioned, that is a sequence of IPs, guys. Okay. And again, in this entire sequence of IPs, you have classifications again. So there's something called as classes, class A, B, C, D, and E. And in each of those classes, there's two subcategories again, public and private, public and private, public and private. Okay. Class D and class A are exceptions. They don't have private IPs in them. All of them are public IPs itself. Okay. So that's an exception to note. Okay. So again, in the next session, in the upcoming sessions, we're going to talk about what these public and private IPs are. Okay, where do we use what category of IPs? What are classes as well? What is the range of each class? What does each class signify? Okay, why do we have 5 separate classes? What do they indicate? What's the relevance of class C? What's the relevance of class B? What's the relevance of class A? Okay, and then some important protocols. What's subnet mask? What is an IP address? I mean, how is a private IP assigned? How do you assign it manually? How do you assign it automatically from a DHCP server? We're going to talk about all this in the upcoming sessions. What's a DNS server? What's the DNS protocol? We talk about all that in the upcoming sessions, guys. Again, apologies for the delay today, guys. It got a bit late due to due to an issue on my end. But yeah, as mentioned, tomorrow we start the session sharp at 7 o'clock and we'll be concluding these other topics. Okay. Yeah, someone has raised a hand. Yeah, Mahid, any questions? You have raised your hand. Mahid, your voice is not audible. I can see your mic is being unmuted, but I still can't hear you. 1 second. Vishwat Mitra, if you have no questions, you can exit the session. As mentioned, we'll be connecting back tomorrow at the 7 p.m. time. Oh yeah, Mahid, you can type, sure.
Okay, okay.
Yeah.
So what is the book actually we have to refer?
What is what? Book to
What
refer?
is the book we have to refer? Yes.
Again, I'll be sharing these documentations myself, Vishwamitra, so you can go through these. Or as time progresses, I'll again review certain books to you, which you can go through later on. Okay, but for now, our documentation is more than sufficient. the documents which I've created right now.
Okay, this the entire classes are there in the Zoom itself right now.
Yeah, Zoom itself, Vishwamitra.
So how many classes? Actually, I missed the yesterday classes.
We didn't take a session yesterday, Vishwamitra, so this is our first session itself. So don't worry, you have not missed out anything.
Okay, this is the first session, eh?
Yeah, first session.
Okay,
Right. Bye-bye.
okay.